As it turns out, illnesses caused by parasite contamination fish is on the rise. The CDC says cases of anacanesis are popping up in the U.S. It's a condition caused by eating fish or seafood contaminated by parasites. Ugh.
As you watch this next report, keep this one fact in mind. 80% of the fish and shrimp we eat in this country is imported. 80% of it shipped here from overseas. Tonight, our investigation has found some of that seafood may contain toxic chemicals and may cause serious health issues over time. Our report from NBC's Jeff Rawson.
Sauteed, fried, or fresh, we love seafood. Appetizing for sure. Until you see where some of it comes from. This video, shot by a U.S. advocacy group, shows dirty sewage water used to raise seafood in Vietnam. The fish pumped with toxic antibiotics and banned drugs just to keep them alive, boosting production and driving down costs.
Would you consider this a public health threat?
Well, absolutely. Who's safe?
Ron Sparks is the commissioner of Alabama's Department of Agriculture. One of the only states testing imported seafood for these dangerous drugs, like chloramphenicol, nitrofurans, and malachite green, chemicals so toxic to humans, they're banned in all food.
In some cases, between 40 and 50% of our tests will come out positive.
That's a disturbing number.
It is to me. That's why we continue to test.
State tests in Oklahoma, Mississippi, and Georgia show similar results, all targeting seafood with the worst record of contamination. Shrimp, catfish, crab meat, and tilapia imported to the U.S. from China, Taiwan, Vietnam, Malaysia, and Indonesia. In many cases, officials say, ending up in our country's restaurants and grocery stores.
Unfortunately, consumers can't tell if any of these compounds are in their seafood. You can't smell it, can't taste it, you can't cook it out.
So how dangerous are these chemicals? Scientists say over time, eating this tainted seafood could cause anemia, cancer, even birth defects. But when you buy seafood, chances are you don't know where it comes from. While federal law requires grocery stores to disclose its country of origin.
Where's the tilapia from?
In restaurants where most of us eat our seafood, it's a different story. Most states don't require them to tell you where it's from at all.
The Mekong River is one of the world's most polluted waterways. Every year, 220,000 tons of industrial waste are dumped into the Mekong River Delta. Rapid development and population explosion have transformed the region from a mainly rural economy to a diverse mixture of industry, transportation, agriculture, and aquaculture. At the same time, catfish farming and processing have exploded along the banks of the Mekong in the last 4 years. Plants able to process as much as 100 tons of fish a day have sprung up alongside factories producing products such as beer or cement. The growth has been so dramatic that even Vietnamese government health and aquaculture officials have warned farmers that their farming practices and water quality do not meet international standards. In 2009, Vietnam exported $4.5 billion worth of seafood, including catfish. In the last 35 years, the population of Vietnam has grown from approximately 35 million to a population of over 85 million. The town of Chau Duc near the Cambodian border is a good example of the effects of uncontrolled growth. Houses on stilts line the river and the city's canals. Sewage from these houses goes directly into the water. Children play in the water. People wash their clothes, their dishes, and themselves in the same water where they raise ducks and throw trash. Lumber is milled here. Salt and ice are also produced. Ships refuel and fishermen still throw their nets for small fish used for fish feed. All this sewage, wastewater, and industrial pollutants end up in the nearby catfish ponds. Vietnamese fish farmers have openly admitted that the number of fish per cubic meter exceeds both Vietnamese and American standards. Often the intake pipes that feed the fish ponds are adjacent to makeshift toilets and busy commercial boat traffic. The outflow from these ponds further pollutes the water. Feeble attempts are sometimes made to filter out debris, but that does nothing to change the chemical makeup of the water. Harvesting is labor-intensive, back-breaking work. The fish are corralled into a pen, then scooped into baskets. Workers carry the baskets to be weighed before they are loaded onto barges, whose holds are flooded with river water. On large catfish farms, sometimes it's necessary to employ motorcycle relays to transport the fish to the barges. When filled to the gunnels, the barges make their way down the Mekong to the processing plants. Hundreds of workers kill, clean, sort, freeze, and package. Catfish, which go by the names basa, tra, and panga, are raised for export to the United States, European Union, and Japan. In 2009, approximately 85 million pounds of the catfish raised in the Mekong River water landed on grocery shelves and restaurant menus in the United States. That's 14 times more than just 6 years ago. And less than 2% of that was inspected by the U.S. Food and Drug Administration. Of the tiny fraction that was tested, much of the fish contained potentially dangerous carcinogens, veterinary drugs, and salmonella, the result of unsafe farming practices and pollutants in one of the world's dirtiest rivers.
If you haven't noticed, almost all the seafood sold in supermarkets now comes from developing nations. Look closely. Tuna from Indonesia, orange roughy from China, tilapia from Costa Rica.
How come everything's from foreign countries?
Foreign fish is cheaper and it's taking over the U.S. market. 80% of all seafood sold in the U.S. is now imported.
Now, I don't think that people have any idea how much imported seafood's coming into this country.
The FDA inspects and tests less than 1% of all seafood imports. And when it does, it frequently finds filthy fish and banned chemicals. FDA records show page after page of rejected shipments. Catfish from China, veterinary drugs. Swordfish from Vietnam, poisonous. Snapper from Malaysia, filthy.
If it's from a foreign country, I'd be very cautious. I wouldn't eat it.
Ron Sparks knows what can be found in foreign fish. As Alabama's Commissioner of Agriculture, he's been to Vietnam and witnessed fish farmed in sewage.
One of the things often found in this imported fish is a fungicide called malachite green. It's illegal to use in food because it causes cancer and birth defects.
Lab tests routinely detect antibiotics banned for use in food in the United States. Antibiotics are used to treat fish raised in crowded conditions that can breed bacteria, viruses, and parasites. Researchers say the chemicals and antibiotics found may not make you sick immediately, but eaten over a long period of time, they pose a significant health risk.
When you go out to a seafood restaurant, what type of seafood do you order?
I don't. Why take the chance?
The ultimate health food, recommended by doctors and nutritionists, fish has retained its image as a healthy and natural product. Yet its flesh holds many secrets, among the most toxic in the agro-food industry.
And now all this fish, because they're too many together, you know, with 2 million in a fish farm like this, they're too many together, and they get sick. And today you have a pandemic because PD and ISA is spread all over Norway, and they don't want to tell it to the customers like the people in France, you know.
Over the last 10 years, Kurt Odegaard has placed these factory farms under strict surveillance, gathering evidence. Today he wants to reveal to me the practices of these Norwegian fish farmers whom he considers so dangerous. In these images, which he filmed, he claims that these men are pouring a powerful pesticide into these waters, one known to have neurotoxic effects. They must protect themselves with work suits and gas masks from chemicals to treat salmon attacked by pests and diseases which abound in these farms.
You will find different kind of ivermectin, you will find flubenzurones, you know, all kind of chemicals, and that's disgusting, you know. It's nothing for people to eat. I mean, you know, Norwegian salmon is the most toxic food you have in the whole world. All kind of methane, and some of these pesticides they're using is the same that was used during the First World War to gas people. They have complete protection, they have gloves, they have everything. You know.
The main problem for Norwegian fish farmers is this parasite, the sea lice. It lodges in the fish flesh and can kill them. Becoming resistant to all the treatments, it forces the farmers to use pesticides, which are more and more potent. These farming conditions produce frightening consequences in the fish, like in these cod, deformed by genetic mutations.
This is a escaped cod from a fish farm, from a cod farm. Nearly 50% of the cod is born like this. They can never close their mouth. This is a genetic damage. It takes 8 generations in the sea to get this away. You understand? Yeah. And female cod of this type is known to get pregnant with wild male cod. See the beautiful faces, you know? Yeah. You don't eat things like this. But if you chop the head off, you wouldn't see it, you know?
Salmon also suffer less visible but equally disturbing transformations.
See, this is a much smaller tail. It has bigger tails with more sharp corners. And the shell is not covering the gills, you know? That's very normal.
What we find inside the fish is even worse.
Typical. This is no. What the hell? See this? This is a fresh salmon, you see? How it's breaking, you see? This is no good fish, you know? This you should be able to tug back and forth. It shouldn't break like this, you know? A wild salmon contains 5 to 7% fat. This contains between 14.5% and 34% fat, you understand? And since the toxic is always following the fat, you know? This is the most toxic food you have in the world. This one is.
Since these fish have more fat, the flesh of farmed fish absorb higher levels of chemical residues. Do you still eat farmed fish?
No. No, I don't.
You've stopped since these studies.
Yeah. You simply must avoid exposure to these pollutants. By ingesting them, you're exposed. That's obvious.
Because it not only is about measuring these pollutants, it's also about evaluating their effects on these laboratory rats.
Here we have a test group that we used as the control group, where the mice ate standard laboratory food and we tested them. Then we had another test group that had exactly the same food, except that we added farmed salmon to it.
For the test group, fed with the farmed salmon, he obtained some very disturbing results.
What we have here is adipose, or fatty tissue from the abdomen. If you look at what happens to the farmed salmon, it's pretty impressive.
Eating farmed fish has made them obese and diabetic.
If organisms are exposed to different pollutants, some of these pollutants are going to make the organism accumulate more fat. So a theory has been formulated which correlates obesity being a consequence of all the pollutants we encounter in the environment.
Around the Baltic Sea, 9 highly industrialized countries, including Germany and Russia, dump their chemical waste. An almost closed sea, whose waters are not renewed for 30 years. The chemicals are concentrated here and end up in the fish.
These pollutants, they bind to the fat in your body, and that's why salmon and herring is extra vulnerable to this pollutant, because you have a very fatty meat, which we like because of the omega-3. But at the same time, they bind a lot of these very, very dangerous toxics.
These chemicals then move up the food chain. The more fatty the fish, the more the pollutants are absorbed into the flesh. Some, such as pesticides or PCBs, are never eliminated and are called persistent organic pollutants. Moving up the food chain, they concentrate more and more in the fatty tissues. At the end of the chain, a kilo of tuna or salmon is much more toxic than a kilo of small fish. Consequently, some fatty fish from the Baltic have become unfit for consumption. So they are harder to find on the consumer's plate. So, they find themselves in heavy demand in the market for making dry pellet fish feed. And that's where the toxicity builds up. Back to Tiburon, in the dry pellet feed plant. To process the fatty fish, Finn Nielsen cooks them in these large ovens. At the end of the line, he obtains 2 very different products. Firstly, protein powder, and secondly, fish oil. These 2 ingredients are used to come up with the finished product, and each of them in their own way will contribute to the contamination of the pellets. Let's begin with the oil. By concentrating in the fatty parts, it accelerates the buildup of the pollutants. This is why farmed fish are more susceptible than wild fish.
These student divers from FGCU are looking for something that could be a lot more harmful than this shark that showed up on one of their dives.
Around the field, we're collecting algae samples.
Algae cells so tiny, I certainly couldn't see them when marine science professor Mike Parsons pulled them out for me at the lab.
You can see them under the microscope.
And that's where they're looking for signs of toxins that when eaten by small reef fish, that are then eaten by big fish, that are then eaten by you, can give you ciguatera.
Ciguatera is a form of seafood poisoning that's caused by toxins that accumulate in fish.
Unlike red tide algae toxins that kill fish, making it obvious we shouldn't eat them, ciguatoxins don't hurt fish, which look and act healthy, and they pass the poison on to you no matter how thoroughly the fish is cooked.
There's no way that we know of yet to remove the toxin from the fish tissue.
The initial symptom, gastrointestinal distress. It can feel like food poisoning, but can get much worse.
It's a neurotoxin, so it'll affect neurons in your brain.
That effect on the brain can be felt as pain, numbness, uncontrollable itching, and hallucinations.
There are cases of symptoms lasting years.
The most severe symptoms are rare and hit right after contamination. A dangerous drop in blood pressure and dramatic slowing of the heartbeat.
Ciguatoxin can be fatal if it's a high enough dose.
Recently, this headline, "New Bride Ordered Fish, It Was a Death Sentence," told the story of a woman who ate cooked grouper on her honeymoon in Mexico and died from ciguatera 10 minutes after being taken to the hospital. While fatal cases are rare, ciguatera is considered the most common marine toxin in the world, showing up in more than 400 species of fish and sickening an estimated 50,000 people every year. Dr. Parsons told me about one of the few surveys done in Florida.
Based on the survey results, they determined that about 1,000 people a year in Florida get ciguatera.
But he also tells me it's tough to tell which of those cases came from Florida fish.
You can catch a fish that was caught in Fiji and be served in a restaurant here in Fort Myers or Naples. There is no way to test if the fish has toxin. It's over 80% of our seafood is imported, and who knows?
They suggest you keep in mind size matters.
If the fish is bigger and older, it's been in the food web longer, so it's been able to accumulate more toxin.
Finally tonight, putting fish to the test. We have reported on the danger mercury can pose to pregnant women, nursing babies, and young children. In some cases, it can harm the nervous system and cause irreversible damage. We know there is mercury in certain kinds of fish, we just haven't known how much. Well, now one company says it may have the answer. Here's ABC's David Muir.
Hey, go enjoy. Have a nice day. Right now, it is impossible to know just how much mercury is in the fish you buy at the supermarket.
You could, for example, have one piece of tuna which could have 300 times the mercury content of another piece of tuna.
But that disparity could soon be revealed. A California company says it's come up with new technology that in just 40 seconds can test the mercury level in a particular piece of fish. And that fish can then be labeled at the grocery store.
They will tell consumers what the average or mean mercury level is for a particular species and what the actual mercury level is for this particular tested product.
But is the mercury labeling necessary? No, says the Food and Drug Administration, which stands by its current guidelines. The fear is that anything more would create needless concern and scare people away from what the FDA considers a healthy food.
Next page.
But this San Francisco mother says the public deserves more.
We were really shocked that, something that comes off your grocery store shelf could be toxic or poisonous.
Joan Davis's 12-year-old son Matthew used to eat fish nearly every day, from canned tuna to sushi to salmon. Her star student began to falter.
He was having trouble forming sentences and doing his writing work.
Blood tests revealed his mercury level was 12.5 times higher than what the FDA considers safe. He is now better, and his doctor says other families could easily be spared.
Now you can test for the mercury content, and people at least will know what they are getting, and it won't be a roulette game.
There is too much mercury in a third of the fish tested by one chemical engineer.
We've tested probably 75,000 fish since 2004. We've certainly found more mercury in fish than we thought would be there.
Mal Wittenberg, with Safe Harbor Seafood Certification, invented this mercury detection machine, which challenges the safety standards set by the FDA. The federal government allows seafood to contain 1 part per million of mercury. That's twice the levels allowed in Canada and Europe. Japan's is even lower. Safe Harbor also sets the limits much lower by taking the industry average for each species of fish, and if the mercury concentration in a sample goes over, it fails. We put Bay Area sushi to the test, taking samples from grocery stores and boutique markets to restaurant chains and high-end sushi houses. Technician Bob Bragg drills out a piece the size of a grain of rice and measures for mercury concentration. First, from Safeway's Deli, sushi made with yellowfin or ahi tuna.
And the mercury concentration is 0.953.
The standard for ahi is 0.4 parts per million, so it's twice the limit set by Safe Harbor. Would you eat it?
No.
In this batch of 26 sushi samples, salmon from Bristol Farms, a boutique market in downtown San Francisco, and hamachi or yellowtail from Japantown's Nijiya Market both failed the Safe Harbor test. Yellowtail from Benihana chain restaurant and more pricey sushi bar Ozumo both hit above the 0.4 parts per million limit set by Safe Harbor and failed. Dr. Jane Hightower, a renowned expert in mercury poisoning, says the federal action level does not take into account mercury can collect in the body, sometimes up to 2 months. She has seen the effects on patients who consumed high amounts of fish known to contain more of the toxin.
The patients had nonspecific symptoms such as headache, fatigue, troubles thinking, insomnia, muscle and joint pain, stomach upset, hair loss.
Dr. Hightower studied patients who were having symptoms of mercury poisoning and found one thing in common. They all ate larger, high-end fish, the kind known to contain higher levels of mercury.
Amongst the fish they were consuming are your swordfish, ahi, sea bass, orange roughy, fish like that.
A particular group emerged with the largest risk of exposure, Asian Americans. Culturally, seafood, including these varieties, are common in the diet.
They are 3 times higher in prevalence to have elevated mercury levels higher than we would like.
Doctors have told us for decades to avoid eating fish that has high levels of mercury. Now, a new study of fish from Hawaii says they're being contaminated by air pollution from Asia. Researchers believe coal-burning power plants in countries like China and India are to blame. CBS News contributor Dr. David Agus is a professor of medicine at the University of Southern California. Doctor, good morning.
Good morning, Anthony and Gail.
Hey.
To start with, how is contamination from Asia, from particularly India and China, getting into fish that we're eating? How does that process work, we think?
Well, they're coal-burning plants there predominantly, and the coal has mercury in it. And so when the coal burns, the mercury goes into the atmosphere, and that's a form of elemental mercury that doesn't hurt you and I, but then it goes by rain into the ocean. And the bacteria there convert it to methyl mercury. The fish can eat it, and then we eat the fish.
Dr. Agus, I keep hearing that mercury is bad. I don't know why it's bad. How bad is it? What exactly does it do to our bodies?
Well, it ain't good. In the 1950s, there was a town in Japan that they started to notice the cats would start to scream spontaneously and birds would fall from the sky. And then the people there started to develop tremors and problems with their memory. And it really was the first case of mercury contamination. It was from a chemical plant there. Mercury, when we eat fish, can cause problems with our nervous system, our heart system, and our immune system. It's really bad for pregnant mothers, young kids who have a developing brain. We don't really know what dose of mercury causes what because we can't do the experiment, right? We can't give somebody mercury and see what happens. But what we know is you want to avoid it as much as possible.
The study also says there's actually more mercury in deep sea fish like swordfish than other fish like tuna.
How mercury causes brain neuron degeneration. Mercury has long been known to be a potent neurotoxic substance, whether it is inhaled or consumed in the diet as a food contaminant. Over the past 15 years, medical research laboratories have established that dental amalgam tooth fillings are a major contributor to mercury body burden. In 1997, a team of research scientists demonstrated that mercury vapor inhalation by animals produced a molecular lesion in brain protein metabolism, which was similar to a lesion seen in 80% of Alzheimer's diseased brains. Recently completed experiments by scientists at the University of Calgary's Faculty of Medicine now reveal, with direct visual evidence from brain neuron tissue cultures, how mercury ions actually alter the cell membrane structure of developing neurons. To better understand mercury's effect on the brain, let us first illustrate what brain neurons look like and how they grow. In this animation, we see 3 brain neurons growing in a tissue culture, each with a central cell body and numerous neurite processes. At the end of each neurite is a growth cone where structural proteins are assembled to form the cell membrane. 2 principal proteins involved in growth cone function are actin, which is responsible for the pulsating motion seen here, and tubulin, a major structural component of the neurite membrane. During normal cell growth, tubulin molecules link together end-to-end to form microtubules, which surround neurofibrils, another structural protein component of the neuronal axon. Shown here is the neurite of a live neuron isolated from snail brain tissue, displaying linear growth due to growth cone activity. It is important to note that growth cones in all animal species, ranging from snails to humans, have identical structural and behavioral characteristics, and use proteins of virtually identical composition. In this experiment, neurons also isolated from snail brain tissue were grown in culture for several days, after which very low concentrations of mercury were added to the culture medium for 20 minutes. Over the next 30 minutes, the neurite membrane underwent rapid degeneration, leaving behind the denuded neurofibrils seen here.